Hey, what's up guys? So we are back with 3.7 this time, and we're talking about some transformations again. So we're talking about more transformations. So this is like stuff from chapter 2, whenever we talked about transformations of quadratics. This time we're talking about transformations of polynomial functions. So how do you transform them? Well, you essentially transform them the same exact way. So you're going to do the same exact thing that we talked about in I think it was 2.1, 2.2, 2.5, 2.6. And now we're going to talk about just using that with polynomials in general, not just a quadratic polynomial. So up at the top of the page here, you'll see a list of transformations. We have horizontal, vertical translations. So these are shifts to the left or to the right or up or down. We have reflections, horizontal stretches and shrinks, and vertical stretches or shrinks. Here's the notation for all of them, which are just the same thing, and then we'll have some examples. But this should be pretty short, but I'm just going to dive right into some of the examples that we have here. So it wants us to describe the transformation from f of x equals x cubed, which is the parent function of the x cubed function, represented by g of x, which is this right here. It wants us to graph. So you notice that this is a cubic function in a vertex sort of form, except that a cubic function doesn't really have a vertex. A cubic function will look something like this. Or, depending on how else it might look at various transformations, it could look something like this, like that. But generally, it should look something like that. So it wants us to graph this function, but then describe the transformation. So if we were to describe, we would just use the same exact notation and same exact logic that we would for a quadratic. So if we have plus 5 right inside here, well then if it's plus 5, that means you're going to move to the left 5 units. So we're shifting. So there's going to be a horizontal shift, left 5 units. Okay, and then right here on the outside, which is plus k, this is going to be a vertical translation up 2 units, or a vertical shift up 2 units. Okay, and I think that should generally be it. We don't have anything else, like anything being multiplied, and there's no negative, so that should just be the two that you have. So if you were to graph this, and I don't really have any graphing space for you guys, so I'll just draw it right here. But the parent function goes something like this, like that. Okay, and so the thing is, we're shifting, and now we don't have a vertex, so we're going to shift just the point right here, the origin. That's what we're going to start by shifting. So shift this instead of the vertex. But like we said, we're going to shift to the left 5 units, so 1, 2, 3, 4, 5. And then we're going to shift up 2, 1, 2. So 5 and 2, so we'll be right there. But we'll take on the same general shape of the graph. So this is g of x, and this is f of x. Okay, let's jump down here, and it says to describe the transformation again, and then to graph. So if you guys want, you can pull out a graphing calculator and graph the parent function if you want to see, and pretty much graph both functions if you want to see what it is, but make sure you know how to describe the transformation. So if we were going to describe, so we have x to the fourth, so that's a quartic function. This will look pretty much similar to what the cubic function looks like. In fact, I can actually show you right here. I'll just go ahead and graph it in here really quickly. So we have x, so this is x squared. Now if you want to do x to the fourth, it looks more like that. So you see that the base is a little bit more wide. Okay, so if we were to describe this function, we don't have any shifts occurring, but we do have a negative being multiplied and a 1/4. So that means if we have a times f of x, so right here, like a 1/4, this is going to be a shrink because it's less than 1. If it's a stretch, it's going to be greater than 1. So we know that we're going to have a shrink, a vertical shrink, by 1/4. And then if there's a negative on the outside, like right here, this is a reflection over the x-axis. So reflection over x-axis. And that's all we'll have there. So if you were to graph this, okay, so the parent function, we just drew the parent function, looks something like this. And then we're going to be shrinking it. The vertex doesn't change, the vertex being right here, but if it's a shrink, that means it should look more like this. I think that that's what it should do. We can go ahead and check it right here. So let's go ahead and add in 1 divided by 4. Yep, so there you go. You can see that we are getting more shrunk. Okay? So this is g of x, and the orange function is f of x. Alright, so go ahead and try and do b on your own. All I can say right here is that we actually have the 2 being multiplied. I can just go ahead and do this. Why not? I'll change my mind. So here's x to the 5th power. So x to the 5th power should still look something like the cubic function, like that. But let's go ahead and check and see what that looks like. Okay. So change that to the 5th. So you can see that it looks more, again, something similar to like x cubed. X cubed, however, you can see that's what it looks like. So the blue is x cubed, the red is x to the 5th. Alright, and then the transformations, if we were to describe, well, I notice here that outside the parentheses we have a -3, so that's going to be a vertical shift down 3. And then we have inside the parentheses being multiplied by 2. If it's inside being multiplied by 2, like we see here, remember that horizontal stretches and shrinks, you have to read backwards. So if it's 2, then it's going to be a shrink. So if it's greater than 1, it's a shrink. And then by its reciprocal, the factor is the reciprocal. So this is going to be a horizontal shrink by 1/2. I won't do the graph, but you guys can, if you want, do that on your own. So let's jump to number 3. Okay, so it says let f of x equal x cubed plus x squared plus 1, and write a rule for g. So we're going to write g of x, and then graph and describe. So here we know f of x is equal to x cubed plus x squared plus 1. G of x is equal to f of negative x. So now we have to write f of negative x. So we can do that by replacing the x values right here with negative x. So f of x is equal to f of negative x is equal to negative x cubed plus negative x squared plus 1. So if I simplify that, this is just going to be negative x cubed. X squared still means it's positive. So that's still going to be plus x squared plus 1. So this right here is g of x. because g of x was equal to f of x, f of negative x. So this is the rule right here. So the transformation that occurred was a reflection over the y-axis. So reflection over the y-axis. And then if you guys want to graph it in Desmos or something, you guys can check it there, but I think that's pretty much all I'll do here. So for b, again, f of x is equal to x cubed plus x squared plus 1, and g of x is equal to 3 times by f of x. So 3 times f of x is equal to 3 times by f of x. Remember that f of x is equal to this right here. 3 times x cubed plus x squared plus 1. Now we have to distribute that 3 inside, so that's going to be equal to 3x cubed plus 3x squared plus 3. And this right here is g of x. Alright, again, if you want to graph that, finish graphing that, I would just recommend using Desmos to help you see what the graphs would look like. Alright, so example 4, we're going to, again, I think so let the graph of g be a vertical stretch by a factor of 2, followed by a translation of 3 units, and we want to write a rule for that. So f of x is equal to x to the 4th minus 2x squared, and it says g is a vertical stretch by a factor of 2 followed by a translation 3 units up of the graph of f of x. Okay, so the first one says vertical stretch by a factor of 2. So how would you write that? So g of x is equal to 2 times by f of x, because that is what the vertical stretch is. So the vertical stretch is this right here. And if a is equal to 2, like it says here, that's what you're going to do, 2 times f of x. So let's do that. 2 times by f of x is equal to 2 multiplied by f of x is equal to this right here. So x to the 4th minus 2x squared. So it's equal to, I have to distribute that, so that's 2x to the 4th minus 4x squared. And I think that should be just as easy as that. But it also says that we're followed by a translation 3 units up. Okay? So now what we're doing is we have to shift it up 3 units. Okay, so now we have to add 3. So this is 2 times f of x plus 3. That's a vertical shift. Alright, so we already know what 2f of x is equal to. We found that out right here. Right here. So 2f of x is equal to 2x to the 4th minus 4x squared. That's this right here. But now we're also adding 3, so plus 3. So overall, it's going to be 2x to the 4th minus 4x squared plus 3. And that should do it. So this should be a very short section. I think I have some example problems for you guys on your notes, and you can do that to practice or ask me questions about in class if you guys come to class. If not, just make sure you email me, and I'll try and help you through emails. But this should all just be pretty old information, and you should be pretty familiar with how to do this stuff at this point. So it's not really that difficult. So yeah, but if it is, let me know. Email me if you have questions, and we can talk about it over that. So yeah, I'll see you guys in class though.